This is CPM Calculus, Chapter 3, number 179. Find the inverse of each of the following functions. Assuming that no domains are restricted, which of the following has an inverse function? How do you know? So let's go ahead and do this. A, we're given f of x is equal to negative 10x plus 8. We know this is the equation of a line. So if it's not a vertical or horizontal line, then we know the inverse of it is a function, right? So the way we like to solve these is basically to find the inverse. Remember, we swap the x and the y, right? That's step one. Step one, we like to swap the x and the y. Well, this we know is just y equals, right? So this is going to be x equals to negative 10 y plus 8. Solve for y. Okay, so let's subtract 8 from both sides. Okay, swap x and y, solve for y. Right, so that's just getting y equals on one side of the equation. So if x minus 8 equals to negative 10y, divide both sides by negative 10. Right, so then we have y equals to x minus 8 over negative 10. Alright, and then that just means that the inverse function, which we write, instead of f of x, we write f to the negative 1 power of x, which is not a power, it just means the inverse function of x equals to x minus 8 over negative 10, right? That's our inverse. Is it a function? Why, yes it is. Yes it is, right? How do you know? Well, you can even, if you graph f of x, so let me graph f of x here in red, let me use blue, because we wrote f of x in blue. So f of x here in blue, we know that it has a y-intercept of 8. So let's say this is 8. And it has a slope of negative 10. That means it goes down 10 and over 1. So it looks something like this, right? Right? And if basically to find the inverse function, you can look at of a graph. If you just rotate this picture right here, rotate it 90 degrees clockwise, right? It's going to be the picture of the inverse function. So if I rotate everything, that's basically means the 8 is over here now, right? You're going to rotate it 90 degrees. This point rotated 90 degrees is over here, right? So it's going to look something like this. You can even graph this. It's going to look something like this, right? And is that still a function? Yes. So how do we know it's a function? Well, if you look at f of x, if you look at it's a function because if you use the pencil test or the vertical line test, you can scan from left to right and there are no repeating values for every x value. Well, if you scanned it from bottom to top, like looking at the range, there are no repeating x values for every y value. So in that case, so no repeating x values for every y value in f of x means the inverse function of x is a function, right? Because the function test, the vertical line test, the finger test basically tells us is it a function or not. And no repeating y value for every x value tells us whether it's a function, right? But no repeating x value for every y value tells us whether or not the inverse is a function. All right, let's go on to part B. Part B, we're given g of x. So let's go ahead. Let's graph this really quickly. Right, this is the parent function is x squared and it's shifted to the left by 4 units. 1, 2, 3, 4. So it looks like something like this, right? So just a parabola going like that. Okay, I could already see that if I rotated this whole thing 90 degrees to the right, including the axis, right? That's g of x in blue. If I rotated it to the right, it's going to look like this. This point's going to be all the way up here at 4. Right? It's going to look something like this now. And so I could already see that the inverse is not a function, right? Inverse before I even find it, is not a function, right? And why is that? Well, if I do the vertical line test on the inverse, it fails. The inverse function of g fails vertical line test, right? So I could have done a horizontal line test on g, and that would have failed and told me the same thing. G of x fails horizontal line test, right? But g of x is a function because normally the horizontal line test doesn't really help us tell whether or not g is a function, but it can tell us whether or not the inverse function of g is a function or not. All right, so let's go ahead and find this. So step 1, right, to find the inverse function of g, we want to swap x and y, right? So then we get x equals y plus 4 squared. And then step 2, solve for y, right? So let's go ahead and first what we want to do is square root both sides, right? Square root of x here equals square root of y plus 4 squared, right? So when we take the square root of a squared, right, that basically meant that it doesn't matter whether or not y plus 4 is positive or negative, because when we square root it, it was already positive. So this means that this is equal to plus or minus y plus 4. Okay, that just means it could be positive or negative. Okay, and what we want to do though, we want to solve for y, so let's move this plus or minus to the other side by multiplying both sides by plus or minus. I know that sounds kind of weird, but if you multiply both sides by plus or minus, you can. That just makes it like this, right? And then we can go ahead and subtract 4 from both sides. And we get y is equal to plus or minus square root of x minus 4. And this right here is our inverse function. So we go ahead and now say g, the inverse function of g written like this, that doesn't mean power or exponent, but that's how we write it, is equal to plus or minus square root of x minus 4. Box your answer. Right? You can go ahead and graph this. It's going to look like this too. And the inverse, again, is not a function. The inverse function of g is not a function because if we look at the vertical line test here, it fails, right? There are multiple y values for x values here. And let's go on to part C of the question. Part C. F of x is equal to x cubed plus 2. Okay, again, let's just sketch it first. We know that this is x cubed is the parent function shifted up 2 units. So f of x looks like this. 1, 2, like this. Right? So that is our parent function shifted up by 2, so that's f of x. Okay, so if we were to go ahead and rotate this entire thing, including the axis, 90 degrees to the right, okay, that would put this function going down like this, right? So it's easier to draw on your paper, maybe, like it's going to be like this, all right? Is that going to pass the vertical line test? Does f, the inverse function of x, is a function, right? Because we're asking, is it a function or not? Yes, it's a function, passes vertical line test. Likewise, we could have said f of x passes a horizontal line test, right? There are no 2 points hit when we draw horizontal lines. So another way we could say it is f of x, I'm going to write f of x in blue, passes horizontal line test. Okay, means the same thing. These two mean the same. Alright, so let's go ahead and find the inverse function of f. So remember, first step, swap. So we get, instead of y equals that, we have x equals y cubed plus 2. So second step is solve for y. Okay, so First, subtract 2 from both sides. So we get x minus 2 is equal to y cubed. The opposite of cubed now, let's go ahead and take both sides to the power of 1/3. So x minus 2 to the 1/3 equals to y. Okay? And let's go ahead and step 3 is always to go ahead and look at our function. And so the inverse function of f is just equal to x minus 2 to the power of 1. Did I say 1/2 here? It should be 1/3. Okay? All right. Let's go ahead and move on to part C. Here we're given h of x is equal to 3 sine of x. I like to graph it first, so let's go ahead and graph it. We know this is just a sine function vertically stretched 3 units. So instead of going and hitting the domain and the range from -1 to 1, it's going from -3 to 3, right? And it's going to look like this, going up to 3, down to 3, and so on, right? And so without even drawing the inverse function of h, I know that this function does not pass the horizontal line test. So therefore, h, the inverse function of h, is not a function because h of x does not pass the horizontal line test. Okay? So if I were to graph it again, I would just go ahead and rotate this whole thing 90 degrees to the right. So that's going to look like this, right? Like that. Okay, so let's go ahead and find. So here is graphed. Let me label it really quickly. In red, we have the inverse function of h, and in blue, we have h of x. Okay, so again, step 1, swap. Swap x and y, so we get x equals 3 sine of y. All right, so what we need to do is divide both sides by 3. We get x over 3 is equal to sine of y. How do we undo sine? Well, remember there's a special function called the inverse sine. So make that the input to the inverse sine. Do that on the left side as well, right? The inverse sine, unwrapped sine, cancels it out. So we get y is equal to the inverse sine of x over 3. All right? That is the graph of it. It is not a function because this does not pass the vertical line test in red, or h of x does not pass the horizontal line test in blue. Okay, so that was good practice doing inverse functions and talking about whether or not a function is, whether or not an expression is a function. Okay, so that ends now CPM Calculus Chapter 3, number 179.